Hello friends, welcome to my channel Math Scout.
Hello everyone. In this video, I will discuss about calculus of variation. Now, this chapter is very important regarding CSIR net. You can see the marks distribution. Last year, from COV, total 3 questions arise, 1 in part B and 2 from part C, total 12.5 marks. So, point of view of marks, it is very important chapter for CSIR net. If you give 7 to 8 hours for this topic, then you will able to attend all the questions in CSR net. Now let's start. Now, what is COV? Calculus of variation is a branch of mathematics in which we deal with finding the function for which the certain integral is either the largest or smallest possible. Now, what is functional? Functional is basically set of functions. It is denoted as jy like this. X is independent variable, y is dependent variable of x, y dash means the first order derivative of y double dash means the second order derivative of y, and etc. We shall consider the functional as I of y x equal to integration a to b f of x comma y dash d boundary conditions. There are three types of Euler equation: number 1, number 2, and number 3. I will not go for the details, just say that use these formulas and find the extremal. Number 1 is very important. In maximum of cases, this formula have been used. So let's see what type of question has arisen in CSIR net. See, find the extremal of the functional Iyx equal to integration 0 to 1 y minus y cube by 3 dx subject to the boundary conditions y0 equal to 1 and y1 equal to 1. Now, to solve this, we have to use Euler equation. So, what is Euler equation? Euler equation of first form is del f by del y minus ddx of del f by del y dash equal to 0. This f is functional, that is, this is the our functional, right? So what is f? F is y minus y cube by 3, right? Then we have to find the value of del f del y. So del f del y means we have to differentiate it partially with respect to y. So what we will get? We will get 1 minus 3y square by 3, that is 1 minus y square. What is del f by del y dash? Now f is y minus y cube by 3. There is no term of y dash, so the partial differentiation of f with respect to y dash is 0. So now put these two values where? In our Euler equation. So what we will get? We will get 1 minus y square minus 0 equal to 0. That is y square equal to 1. After simplifying, we will get either y equal to 1 or y equal to minus 1. But here we can see that y0 equal to 1 and y1 equal to 1. So this case is not possible. Only possible value for y is y equal to 1. So this is our extremal. Fine. Now see our next example. Now our second example, Find the extremal of the functional I of yx equal to integration 1 to 3 3x minus y into y dx subject to y1 equal to 3 by 2 and y3 equal to 9 by 2. Now what we have to do to solve this question? We have to write the Euler equation, right? So what is Euler equation? Euler equation del f by del y minus d dx of del f by del y dash equal to 0. What is our f? This is our f, right? So what is f? F equal to 3x minus y into y. So we have to put this value of f here and here, right? So what we have get? So what we will get? Del f del y equal to, now see, for simplification we'll multiply this y with this two term, right? So we'll get 3x minus 2y. Now what is del f by del y dash? It is 0 because there is no term of y dash. So partial derivative of f with respect to y dash equal to 0. Now putting this value here and here, we will get 3x minus 2y minus d dx of 0 equal to 0, right? That is 3x equal to 2y. So what is the value of y? We have to find the value of y. It is 3 by 2 into x. Now we have to check the boundary conditions, right? We have to check the boundary conditions here. At 1, the value of y is 3 by 2. So if we put x equal to 1, we will get y equal to 3 by 2. And at 3, the value of y is 9 by 2. If we put x equal to 3, we will get 3 into 3 by 2, that is 9 by 2. So okay, so this is our extremal value of y. So this is our extremal. Again, we will see another example. Let's see. This is our example number 3. I of yx equal to integration of a to b y plus y cube by 3 dx, where ya equal to 0 and yb equal to 1. Find extremal. To find extremal, we have to put Euler equation. What is this? Del f by del y minus d dx of del f by del y dash equal to 0. What is f? That is what is functional. Our functional is y plus y cube by 3. If we put here, so what we will get? We will get 1 plus 3y square by 3, that is 1 plus y square, right? Minus d dx of del f by del y dash. No term of y dash, so this term will be 0, that is y square equal to minus 1, right? So what is the value of y? The value of y is plus minus I. But the boundary condition, it is given that ya equal to 0 and yb equal to 1. So no term of x is here. So this solution contradicts our boundary conditions. So what we can conclude? We can conclude that there is no extremal. So you have to be aware about that. In CSIR net exam, there will be 4 options, and suppose one option is there is no extremal, and you just calculate and you have find a contradiction, then you have to be aware that answer will be there is no extremal, right? Now see, this is the question from 2022, and this question came in part B. Now to solve this type of question, what we have to do, we have to write Euler equation, right? Euler equation. What is Euler equation? We know that the Euler equation is del del of y minus d dx of del del y dash equal to 0. So what is the f here? F is this, that is f equal to y dash square minus 2xy. So what is the value of del f del y? If we put this value here, then we will get minus 2x, right? Because the partial derivative with respect to y equal of this equal to minus 2x minus ddx of del f del y dash. Now see here in f there is a part of y dash square. So the partial derivative with respect to y dash equal to 2y dash. So after calculating, what we will get? We will get minus 2x minus, now the ddx of 2y dash. What is the meaning of that? The meaning of that is 2 double y dash, right? Because 2 is constant term and the derivative of y dash is y double dash, which is equal to 0. What we have to find? We have to find extremal, that is the value of y. So this is equal to, so 2y double dash equal to minus 2x, right? So what is the value of y double dash? The value of y double dash is minus x. Now to find the value of y, what we have to do? We have to integrate, right? Because you have to find the value of y. Here we have given the value of y double dash, so we have to integrate with respect to x. So y dash equal to minus x square by 2 plus a, where a is arbitrary constant and integration constant, right? Now again we have to integrate y dash. So y equal to minus x cube by 6 plus ax plus b. Again b is an integration constant, right? Now you can see there are two arbitrary constant. We have to find the value of a and the value of b. How? Now see, we have given two boundary conditions, right? Y of minus 1 equal to minus 1 and y of 1 equal to 1. So use it. We have given what? Y of minus 1 equal to minus 1. So after putting minus 1 in place of x, we will get minus 1 equal to minus minus 1 by 6 minus a plus b, and also we have given that y of 1 equal to 1. So if we put x equal to 1 here and here, we will get y equal to 1. So 1 equal to minus 1 by 6 plus a plus b. Simply if we add these two, we will get 0 equal to 0 plus 0 plus 2b. So b equal to 0, right? We will get the value of b. Now we have to find the value of a. If we replace b equal to 0 either here or here, what we will get? We will get the value of a, which is 7 by 6, right? So what we will get? We will get the value of a, that is 7 by 6, and the value of b, which is 0. Now replace these two values here, then we will get y equal to minus x cube by 6 plus 7 by 6x plus 0, that is minus x cube by 6 plus 7 by 6x. Now check the options. We'll see that D is our correct option. Fine. Now proceed for the next question. Let x equal to u belongs to C1 0, 1 closed interval such that u0 equal to 0. Let I from x to r be defined as I of u equal to integration 0 to 1 u dash t square minus ut square dt. Which of the following is correct? I is bounded below, I is not bounded below, I attains its infimum, I does not attain its infimum. This is for 4.75 marks. Now, what we have to do to solve this question, we have to use Euler equation, right? What is Euler equation? We know del f by del u here, because here the dependent variable is u, not y. So we'll write u in place of y minus dd of x of del f by del u dash equal to 0. If you face any problem, then you can do this problem, keep y, and in final answer replace y by u, right? Now, what is the functional value? That is, what is f? F is given as u dash t square minus ut square. So f equal to u dash square minus u square. If we look here, the independent variable is t, not x. So we have to put here t, not x, right? So what is del f by del u? Del f by del u means minus 2u, and del f by del u dash equal to 2u dash. So these and these value, if we put these two values here, then we'll get minus 2u minus ddt of 2u dash equal to 0, right? So minus 2u minus, what is ddt of 2u dash? This is 2u double dash equal to 0. That is u double dash plus u equal to 0. Now, what is it? It is an ordinary differential equation. So, to solve, what we have to do? We have to use auxiliary equation, right? So, auxiliary equation will be m square plus 1 equal to 0. Then what is the value of m? The value of m equal to plus minus of I. So using CF and PI, we have to do the solution, right? So what will be CF? CF will be C1 cos t plus C2 sin t, right? Because we know that if the root is alpha plus minus of I beta, then the CF will be e to the power of alpha t into C1 cos beta t plus C2 sin beta t, right? Here alpha is 0, so e to the power of 0 is 1, and beta is 1, so C1 cos t plus C2 sin t. This is our CF, and since the non-homogeneous part is 0, so no pi, so u equal to C1 cos t plus C2 sin t, right? Now this C1 and C2 are two arbitrary constant. To remove this, we have to use the initial condition. Now here, given that u0 equal to 0, right? So if we put what we have u0 equal to 0. So if we put t equal to 0, and then we will get y equal to 0. That is C1 cos 0 plus C2 sin 0, and sin 0 is 0, cos 0 is what? Cos 0 is 1. So we'll get C1 equal to 0, right? That is u equal to C2 sin t. Now see the option. Option 1 states that I is bounded below. Option B, I is not bounded below. Option C, I attains its infimum. And option D, I does not attain its infimum. Option A is right and option B is wrong. Why? Because here we see u equal to c2 sine t. This is an oscillatory function. Oscillatory function, right? This is an oscillatory function, and this is bounded by what? This is bounded by, it goes 0, and it is bounded by plus c2 to minus c2, because sine is bounded by plus 1 to minus 1, and if we multiply this by c2, so the upper bound will be plus c2 and lower bound will be minus c2. So the option A is right and option B is wrong, because I is bounded below. Now what is option C and option D? I attains its infimum, and D, I does not attain its infimum. Here, if we find the boundedness of U, then we'll get U is bounded by C2 and U attains the value of C2, right? U attains the value of C2, that is U is less or equal to C2 and greater than equal to minus C2. So U attains its infimum and supremum both. So my friends, this is how you have to proceed for this type of question. Practice and practice more and more. In the next video, I will show the more concepts about COV and more types of question which have arisen in CSI NET exam.